My name is Arun Gupta, and I work for Oracle. This talk is about Java EE 7 platform, how it can help you improve your productivity, and what are we doing as part of the platform. I was thinking, well, we have two options, and we can go either way. By a show of hands, the two options, first of all, are I can use slides, talk through them, and show you exactly what's coming in there. Or the other option is I can use no slides, absolutely no slides. I can let the code do the talking. I will show you a bunch of code and show you exactly how the whole thing works. So option one, two hands for slides. Option two, I guess this is a developer conference, so no slides. Okay, this is purely then a code-driven session. And as you can see, I have NetBeans open live now. This is a 7.3.1 development release. What I'm going to talk over here is, well, first of all, Java EE 7 is a major update of the Java EE platform. Now, Java EE 6 was the last one. It was released in December of 2009, so over 3.5 years ago. And Java EE 7 is now ready for launch next week. Literally June 12th is when the online launch is going to happen. As part of that, we have added 4 new specifications to the platform. So there is a first-class support for building WebSocket-driven applications, and I'll show you how we do that. I will show you how there is first-class support for Json processing. I'll talk about that. How there is support for batch applications. You no longer need those third-party proprietary APIs anymore. And there is support for concurrency utilities. So once again, JSON, WebSocket, concurrency, and batch. That's the new functionality coming in as part of the Java EE 7 platform. And then JAX-RS 2, JMS 2 have been majorly updated. I will show features of that. What are we doing exactly around those lines? In terms of, in Java EE 6, we introduced this concept of a web profile. So web profile is what is targeted towards application of modern application development. Like, let's say if you don't need JMS and RMI, IIOP interoperability and things like that, you can just do web profile, small size, 30 megabyte download, and you get started with it quickly. Same way, we have a web profile as part of Java EE 7 as well. And the 3 additions really to web profile are, first of all, is JAX-RS 2.0. JAX-RS is the first addition. In Java EE 6, it was not added primarily because of timing, scheduling constraints. And then in addition, we actually surveyed community members on what other technologies they would like to see as part of web profile. So JSON and WebSocket are also part of web profile as part of Java EE 7. So that's sort of how the web profile in the full platform works. Now, if you need batch, concurrency, the whole thing, then of course you can have the full platform implementation of Java EE 7. With that, let's get started. So I have a whole bunch of samples, like about 200 plus samples. I'm just not gonna go through all of them in 1 hour, but my goal is to pick and choose certain specific ones which will highlight what the capabilities of the platform are. So the first one that I want to start with is like a WebSocket one. And if you were at my WebSocket talk, then this would be sort of a repeat from that. But the idea is, what is WebSocket? WebSocket gives you a full duplex bidirectional communication over a single TCP channel, which is way better than traditional HTTP REST because it's a single TCP connection. You don't have to establish a HTTP connection or a TCP connection every time you want to send a request. You don't have to send those chatty HTTP headers. None of that requires. WebSocket is a very lean protocol. Specifically with these days, with HTML5, gaming, mobile gaming, low bandwidth, this is very efficient. So what I'm going to show you is a simple application which allows you to build a collaborative whiteboard. The idea is collaborative whiteboard, but can be very easily extended to an online game, for example, 2 players playing across the internet. Let's play the game first. And then I'll walk you through the source code as well. And here's how my game looks like. Well, that's one browser. What I'm using here is Chrome, and I can bring up the same game in Firefox as well. So on the left, what I have is Chrome browser. On the right, I have Firefox. These two could definitely live across internet, all those things. That is very much a reality. This application would run on any HTML5 compliant browser as such. Okay. Now let's say in terms of the game, whatever I'm clicking here is getting reflected on my other browser as well. I can change the shape here and then gets reflected as well. I can change the color here and that gets reflected too. So whatever I'm clicking on one, the idea is if there are two players playing, if they're clicking on either of their games, game screens, that would get reflected on the other browser or the other player's game screen. Now same thing, if I go here, if I click a few squares here, I go back here, the same squares are reflected here. So it's literally a two-way communication, client to server, server to client. Now what happens if you go offline? Let's say you're saying, I'm not connected to the net now, or I've lost the connectivity, very typical. Then let's say you change the color, you clicked around, whatever you're clicking is not getting reflected on the other browser. Now let's say you do come back online, but now even though the state is both online, but the games are out of sync. So how do you update the other player? So you send a snapshot. Okay, so a typical concept, but what I'm going to show you is the code behind this to help you understand how WebSockets work. So first thing, if you want to build a WebSocket, you have to have a WebSocket endpoint. In terms of an endpoint, the WebSocket API or Java API for WebSocket allows you to define a WebSocket endpoint annotated or programmatically. What I'm using is an annotation. So line 57 is what is my server endpoint, which says, okay, this Pojo is my WebSocket endpoint. And this is available at the URI/WebSocket. Now, it's specifying the URI where my WebSocket endpoint is listening. Now, a WebSocket can send a text data or a binary data, but you may not want to deal with the text and binary data in its raw form, as in raw text and raw binary. What you want to deal with is how I can convert that text/binary data easily to my business domain objects. In my case, it's a figure object. So effectively what's happening in my HTML5 canvas, every time I'm clicking, I'm capturing the shape, the color, and the X and Y coordinates of where I'm clicking. I'm building that as a JSON structure, sending it over to server. But that's text. Do I need to have a JSON parser library to deal with that? No. So that's exactly where your WebSocket encoders and decoders come in. As part of that, what you're saying is, I have a decoder which will take my JSON text as is, convert or decode that text to a Pojo. Similarly, if I'm sending a response back, I may be sending a response back as a figure object. In that case, I'll have an encoder which will take a figure object and encode it to the JSON text. So my encoders and decoders are specified here. I have lifecycle callback handlers in WebSocket, which says if a client is connecting to my endpoint, call this callback handler, or if any client is connecting to my endpoint, call this callback handler. In this case, what I'm doing is I am maintaining a set of sessions. Session is my client endpoint or the client that is trying to connect to me. And all I'm doing is I'm adding that session object to the set. Similarly, on onClose, which is line 69 here, I'm saying every time a client is disconnecting, remove it from the set. So the idea is at any point of time, the set has the complete set of clients that are connected to you. Now, as I said, we have the JSON text going back and forth, but I want to deal with my figure object. So what I'm doing is I have my figure object. If you receive a WebSocket message, then you want to dispatch that WebSocket, or you want to have access to the payload in a business method. And that method really is identified by @onMessage annotation, which is line 74. Now it's shown number here, or line 74. Now, what I'm saying is, this is my figure encoder decoder. I'm receiving a text data. This encoder and decoder encodes and decodes from text. So this method will be dispatched if I receive a text data that can be encoded to figure. And so this method is called. And in this method, effectively, all I'm saying is I'm iterating through all the clients that are connected, and I'm broadcasting the same shape, figure, XY coordinates to all the clients, which then refresh themselves. Similarly, if WebSocket sends binary data, in our case, the binary data is when we click on the button send snapshot. In that case, it's just taking a HTML5 canvas, a snapshot of it, and saying send this as a byte buffer or array buffer. Array buffer is a JavaScript binary type. Now that is being received as a byte buffer or even as a byte array in your Pojo endpoint here. So that's sort of your Pojo code here. If we take a look at the index.jsp, that itself is pretty vanilla. Nothing fancy there. Just got some headers, my canvas here. Then I got some radio buttons. This is color, shape, and then I got some buttons which says, you want to send instant or send a snapshot. And then I have my WebSocket.js file. If you want to connect to a WebSocket endpoint, you have to use the URI called as ws://. You don't use the HTTP URI scheme. Now, the moment you say ws://, it do the data handshake. It does the connection negotiation in the sense, there's a handshake defined in the WebSocket protocol, which says, okay, you can take an HTTP connection, upgrade it to a WebSocket, and then do the WebSocket protocol exchange after that. So the moment you create, well, first of all, you make the URI, which is saying host, port, path name, etc. This is the URI where my endpoint is listening. Then you say new WebSocket. This is a new JavaScript API, which allows you to make a connection to a WebSocket endpoint very easily. Well, this is the only way that you can do connection to WebSocket endpoint today. I'm setting the binary type as array buffer. Just the way I have on Java side, I have my callback handlers. Same way, I have callback handlers on the JavaScript type. And I'm setting those. So if I look at on message, for example, in on message, that means I'm receiving a message. Once I receive a message, all I'm saying is, oh, if the data type is string, that means I know I just need to update a specific object in my HTML5 canvas. And if I'm receiving a snapshot, then I need to update the entire HTML5 canvas. So that's the on message. But if you look at send text and send binary, those methods are pretty simple. Just say WebSocket send, WebSocket send. And the only intent here is to kind of highlight the semantic nature of it. The syntax is exactly the same. Now, looking a little bit more at the Java code. So this is my figure decoder, which says I'm going to decode a text message here, essentially taking a string, converting it into figure. And in this, whatever your logic is, in this case, what I'm doing is I'm using the standard Json Processing Api, which is again a new API added to the platform, to take the string data, converting it into a JSON object, and letting it populate the figure object. Okay, so that's my simple sample of WebSocket. Okay, let's take a look at another sample. The next thing I'm going to jump on is a simple batch sample. Now, batch applications is a standard way. The batch API is a new API added to the Java EE 7 platform. It allows you to create batch applications using standard APIs. So you don't need to use any of those proprietary APIs with this anymore. Now, in terms of batch, it defines the concept of, there is a job operator which knows how to operate the job. There is a job repository where all the jobs are stored. There is a job definition, which is effectively defined as a deployment descriptor or a job XML. And there are reasons to do that. But those are the basic concepts that are very well known in the batch world effectively. Now, in addition, the batch API defines two concepts called as chunk and Bachelet. The chunk is a concept where, chunk is more like item-oriented processing, where you read an item, you process an item, and then you aggregate it for writing. So you read and write an item, read and process an item multiple times, and then you give it for aggregation to writer, and then writer writes it out. Think about the use case where you are reading the records from a CSV file. So let's say you're reading the record from a CSV file, processing it in the sense of validating it. Is the record valid or not valid? And then you're saying, okay, I'm done validating. You give it to writer for an aggregation. You do that maybe say 10 times, read, process, and then in the writer, when you have given it for where you have given it for aggregation, it will probably make one database call to write those validated records. Now, in that process, there are mechanisms by which you can say, oh, this record is not valid, so don't write it, so it won't be aggregated. You can also have mechanism to saying, that's the last record I want to process. There are mechanisms for that, very straightforward. The entire chunk, read, process, and write, all of that is inherently done in a transaction. So the idea is there is no need for you to explicitly start a transaction. So that's completely inherent, just works out of the box. And think about if you're reading like say 1 million records, and if you have done like 800,000 records, and let's say an error occurs over there. So same thing, in the chunk concept, there is a concept of checkpointing. If you, by default, it reads 10 items, like, reads, process, read, process 10 times, and then writes those 10 items. If you have changed the chunk count or item count, so to say 100,000, then there is automatic checkpointing that is occurring as well. And you can resume from the last checkpointed item. Now, chunk is one way by which you can do, that's the preferred way of doing batch processing. There is another style called as Bachelet, which allows you to do a custom, roll your own sort of a batch processing job. Not going to focus more on that because the preferred style is batch chunk. So let's take a look at chunk. The entry point to any batch job is a job XML. It's defined as a job XML. And there's a reason we stick around with job XML here because, well, first of all, a lot of it is borrowed from Spring Batch. So if you have been dealing with Spring Batch, this would be a little bit familiar. The reason we stick around with XML in this case is because there was a discussion in the expert group to use only annotations, but then the job could be really complex, and capturing that in annotations would be really, really tricky. So in the first version, at least, it's only deployment descriptor based. Maybe in the subsequent versions, we will take a look at it if it could be done using annotations. It's basically defining a new DSL altogether. Now here, I have a simple job. This job has one step, but in a typical job that you want to run, there will be multiple steps. So you could have multiple steps within the job. There are full complex workflows, decisions, all of those concepts are available to define as part of your job. Now this job has one step, and the step is of the type chunk. By default, as I said, the item count is 10. In this case, I'm explicitly overriding it, saying it's 3. That means I'm going to read, process, read, process, read, process. That's 3 times. And then I'm going to write those 3 items at one go. Now I have reader, processor, and writer items over here, and they have references. Those references essentially are CDI bean names that are bundled as part of my WAR file. Now this is a simple web project deployed as a web archive. So in that web archive, somewhere I have those beans, and those beans have their names resolvable to these names. Now if it's in a WAR file, then your batch XML or job XML has to live in the metainf/batch-jobs directory. That is the specific directory required. You also give it a name like myjob.xml. We'll see where that my job is being used. Okay. So first of all, let's take a look at my reader, processor, and writer. This is my item reader, very simple over in this case. It's just extending a convenience abstract class. You can always implement an interface if you want to implement all the methods. I have an open method that I'm overriding here in this case. This is exactly where you initialize your resources, whether I'm going to read from a stream or a reader or from a queue or whatever it is. For convenience, I'm just using a string tokenizer, just for simplicity, no big deal. Now, read item is the method that is returning the items as they are being read. So effectively, let's say in your open method, you have opened a stream, which is a CSV file. That's where your stream is open. In the read item, you will read line by line, and you will read one record at a time, or you will return one record. The idea over there is you have a true separation of concerns. In reader, you read the record. You're not processing the record in any sense. If you go to processor, just implements an interface, single method over there. So whatever item you return from read item is automatically available as a method parameter over here. So in this case, all I'm doing is, well, let's take a look at reader once again. So this is a string tokenizer from 1 to 10. So effectively, I'm returning 1, 2, 3, all the way up until 10. So I have 10 records. And I'm just creating a my input record over here in this case. If I take a look at my input record, it just takes an integer identifier and returns the value here. If I go back to my processor, so effectively in my processor, even though it's synced object, but I'm getting my input record here. Now from the my input record, I check whether the ID is odd or even. If it's even, I reject the record by returning null right here. And if it is valid, if it is not, that means it is not even, then I create a new output record. My output record is very similar, nothing fancy, just same integer, constructor, all those things. But the whole idea over here is, in your process item method, which is on line 52, you could receive a different kind of record, and you can return a different kind of record altogether. For example, in a CSV thing, I could receive a string, and I could do the processing of the string, splitting up the records, and I could generate a JPA entity and return from here. So that is truly the model that we are planning to support here, or that is intended to support. Now, in this case, all even number records are rejected, odd numbers are returned, and what I'm doing is I'm just doubling the value of the odd number records. Now, if I go to my item writer, here again I'm extending a convenience class. The write items method takes a list. This is where the aggregation happens automatically. You don't need to aggregate it. As long as you have implementing the right interfaces, the item that is being read is automatically passed from reader to processor, and from processor to writer for aggregation. And as soon as the item count that is defined in our job XML is reached, that entire thing with reader, processor, writer, that writer triggers, writes it to the data store. In this case, I'm just printing out the values, and then the transaction is committed. So all of that is inherently transactional with frequent checkpointing. So if I were to run this, well, that's how all the artifacts are hooked up together. Let's see how we trigger the job first of all. In this case, I have a simple servlet. The code may look a little bit convoluted, but this is just a sample here. Line 85, basically what I'm saying is, I'm saying to the batch runtime, give me a job operator. Okay, so this is the only code. The highlighted code is the only one that I want you to look at. So I'm saying to the batch runtime, give me a job operator. And to the job operator, I'm saying start my job. And when I'm saying start my job, I'm actually giving it the string called as my job. That my job is the same thing, if you remember, is the name of my XML file. So it picks up that job, triggers the job, step, chunk, reader, processor, writer, all that, and then commits the entire job. Now, I could conceivably have many job XMLs in my batch jobs directory, And that way, there is a capability by which you can pick and select the job that you care about. Now, starting a job returns a job ID. That job ID is your unique identifier, which you can use to abandon or restart or cancel the job if you want to. And that's what the stuff on the bottom is doing over here. For example, I'm saying, show me how many times this job has been run, or what is the job execution status, what is the create time, start time, etc. So all that metadata is available to you. Something that I've not shown you here is, or maybe it's worth showing actually. Well, first of all, let's run this job. Okay, so right click here and say run it. I'm going to start the job here. It's going to start my batch processor, the whole thing in the background, does something, returns the response back to me, the metadata. But what we care about is the output that is being printed for us. So if we take a look at that. So this is the output that is being returned to us. It's saying in my process item, my input record 1, 2, 3, but output number 2 or record number 2 is being rejected. 1 is doubled up to 2, 3 is doubled up to 6. So 3 records being processed at one point of time, first and third picked up, second being rejected. Same thing here, 4, 5, 6. So 4 and 6 are rejected, record number 5 is taken, doubled up, and 10. 7, 8, 9, again record number 8 is rejected, and finally you have one record that's automatically going through. Okay? So that's how your automatic checkpointing, transactions, everything works by itself. One second. So here, for example, I'm just showing you another job XML. I'm not going to run this job. But in the job, I have a step, and it has another step. So I could have 2 steps. And then in this one, for example, I'm saying, oh, my logical identifier is step 1, but the next step that I want you to execute is step 2. And in this one step, I have chunk, and this step is a bachelet. So you can do those mixing and matching of how the chunks and the bachelets are mixed up. Here is another sample of a job, a little bit more complex and involving. So for example, I have a step. So this is all one step, by the way. In that step, I have a chunk. In the chunk, I have reader, processor, and writer. Okay. Now the reader is optionally passing certain properties, so start and end. So for example, let's say you are all reading from a same CSV file, but instead of one reader, one processor, and one writer doing the entire thing, I may want to say, reader, I may want to run it on multiple threads. Let's say if a 4-core machine, I may be able to spin up to 4 threads. How do you indicate that in your job XML? So in this case, in the chunk itself, I've added an element called as partition. That's a new element part of job XML. In the partition, I'm saying I'm going to run it in 2 partitions, and I'm specifying the properties. In the properties, I'm saying, okay, the start value is 1, the end value is 10. In this case, the start value is 11, the end value is 20. So effectively, if I have, say, 2 million records, then I could say the first million records are being read on one thread, and then the second million records are being read on the second thread. So you're basically splitting up the job. Similarly, your processors and writers work accordingly as well. And once again, all of this is inherently transactional. There was a question here. Yeah, sorry, the question is, the first question was, instead of saying batch runtime.get job operator, I would like to see it being injected. I agree. There's a RFE file on the spec for that already. That's a clunky job, in my opinion. The second question was that the quads team, they were kind of afraid of going down the workflow route because then it's not just workflow. There are a lot of other components get involved as part of it, and that was a comment. But the question really was, is this really become sort of the workflow, and are there bigger discussions happening around how a broader workflow could be defined as part of Java EE? So the answer to that really is, in this case, in batch at least. Now this is only for batch. We have, what I'm showing you is a simple partition. There are concepts of decisions, splits, flows, all of that. So all of that discussion has happened within the context of batch, for now at least. Now in terms of Java EE 8, I don't think it's on the table yet, but that does not mean it's not going to get done as part of Java EE 8. Because really we are just too focused right now to deliver Java EE 7, which is going to be next week. And then after that, all the discussions around the scope and what features do community care about would be on the table at that point of time. But yeah, batch already supports, and it's not a full workflow anyway. You can actually use your decisions, splits, flows, but that's purely within that's purely within the context of batch. For example, oh, this job failed, so what you should do that. But it's not, and there are concepts by which it can delegate to POJOs as well for making those decisions, but it's purely within batch concept. All right, I'm going to start with a new sample here. Let me show you some JMS improvements that we have done. Now, JMS, the last version, if you realize, was done in December of 2003. So like JMS 1.1, so almost 10 years ago. JMS 2.0 is a big improvement on top of JMS 1.1. Most of the work has been focused on simplifying the API, making sure we leverage all the modern language features from the Java EE platform. So that's been the focus primarily. Specifically leveraging CDI pretty significantly. So let me, actually, if I can show you a different sample. Now, JMS 2.0 supports both the older style API and the newer style API. The older style API is called as the classic API, and the newer style API is called as simplified API. We have to maintain backwards compatibility. So this is the code that you have to write to send a message using JMS 1.1. And I'm sure you can improve the code, but try to understand the points here, first of all. On line 58, I'm doing a lookup of the connection factory. On line 61, I'm saying, OK, this is my destination where I'm going to send the message. Then I have a send message method where I'm doing, honoring the API. Oh, from the connection factory, create a connection, then create a session, then create a producer, then a text message. My real intent is only line 71. I just want to send the message. But you have to honor the API the way it's being defined. And then there are checked exceptions. So you have to make sure that the exceptions are caught properly. And then you need to close the resources. So a whole lot of boilerplate code that you need to write just to get that job done. Let's see how we have improved that as part of JMS 2.0. That's all the code that I need to get it working, okay, to send a message. Let's take a look. Jms Context is a new object introduced as part of JMS 2.0, which basically encapsulates your connection and the session object that exists in classic API or the older API. So all you need to do is, instead of saying I want to create a new connection or a connection factory, nothing of that sort. You just inject your JMS context. The container will automatically inject it for you. It's a container managed context, effectively. Then, of course, you need to point to your destination. But in addition, this destination could actually be created as part of your application itself. So we have introduced new annotations called as Jms Destination Definition. So if I can show that to you for a second. So I have this new annotation called as Jms Destination Definition. This could be put on any of my EJBs or servlets, etc. And then there I'm specifying what destinations need to be created. So as part of your application deployment, these destinations would be automatically created for you. So for example, in my application here, if I take a look at not here, but right here. So in my, say, simplified message receiver, I have the JMS destination definition. I just put the annotation, I put the name and the interface name, that this is a queue, and that's it. Then this will automatically create my destination for me. Well, of course, you can go the application server specific way, use, for example, Glassfish, CLI, or admin console to create this, but this simplifies it, lowers the bar for you. Now going back to my sender, simplified message sender. Okay, so first of all, I inject my JMS context here. Now notice I am not pointing to a connection factory here, and there's a reason for that, because the spec says if you do not point to a connection factory, then we automatically use the default connection factory. First of all, the platform itself defines a new default connection factory. Not only a new default connection factory, it even defines a new default data source for you. So for example, if you were to injecting JDBC, if you want to inject a persistence unit, or in a persistence unit you don't need to refer to a JTA data source. There is a default connection source that it will point to, which will point to your application server specific JDBC resource. So all of that completely automatic, and I'll show you a sample for that. So coming back here, actually, I'm injecting my JMS context. I'm pointing to my resource that is created by my application. Then on the context, we're using a Fluent API, builder pattern. So on the context, I create producer. Then I say send to this destination, and that's the message. No more wrapping. Everything is a runtime exception. You take care of it only if you want to. The resources are automatically closed for me. So we are actually making them, try with resources completely. Basically implementing auto-closable interface. So not only the amount of boilerplate code is cut down, but it actually improves the semantic readability of my code. I can look at the code. I don't need to comment it anymore. In this previous case, yes, you will need to comment it. And one of the funniest comments typically goes over these two parameters, because we say that in this case, I'm doing it in an EJB. So the EJB spec says if you're using classic API, I'm going to ignore those two parameters. Why? Go ask the EJB spec lead on that. But that's the nature of it. Okay, so those are sort of my improvements in JMS. Let me show you a simple sample on what improvements we have done for JSON actually. So what I just did was I invoked Facebook's public API, and I'm searching for the keyword Java, saying search for the query Java on all the public posts, and it returned me the result set. Now that's result set comes as a JSON structure. So this is a fairly comprehensive JSON structure, data array with bunch of name values, with nested objects, etc. Okay. I'm going to show you the JSON Processing API that has been added to the Java EE7 platform, how we can use, well, first of all, in JSON processing itself, there is a streaming API, which is more lower level API, which generate events, start object, end object, start of an array, so on and so forth. And then there's a higher level object API, which allows you to read the entire structure as one full object. Then you can index within the object very easily. So here, for example, let me show you what I'm going to do with the object API. Same URL I've mentioned here. Then I'm opening the stream. I'm creating my JSON reader. That's the new API. By the way, it's in JavaX JSON package. Then once I get my reader, from the reader I read the object. But once I've read the object, the entire structure is read into the memory. And then once it's in my memory, then I can say, okay, give me the JSON array. Then I can start indexing. Okay, from the array, I want the from element, from which I want the name element. So get JSON object, get string. Or I want the string message. Okay, so that's the object API. In terms of the streaming API, similar start. I basically point to the URL. I get my JSON parser in this case, not a reader. But once I get my JSON parser, I can actually listen for the specific events that I care about. The parser is reading through my JSON structure. It's going to spit out events like key name. Okay, oh, key name and counter. It doesn't care what key name it is. It just knows it's a key name because JSON is basically a finite structure which says exactly how this is going to look like. So here it generates a key name event. That's the event that I care about. Then on the key name, I say, okay, show me what is the key name now. The real key name. If the key name is name or message, then I want to do something about it. And effectively what I'm doing is, so once I know the key name, then go to the next element, which is parser.next. And now if the element next to key name is the value, then I'm saying give me the value, and I'm printing it out. So you can see there is a streaming API, there is a object model API for JSON processing, very well integrated as part of the platform. Okay, let me show one more thing here. We talked briefly about how we have a default data definition or data source as part of the Java EE 7 platform. Now, typically when you're building a Java EE application, it's typically a database driven application. So you would need some sort of a connection to the database. Most of the, runtime requirement for a Java EE 7 container is to ship with the database. So if you ship with the database, then typically your application server would provide your specific JDBC resource, but then that's application server specific. You don't know what that name is going to be. In some cases, it's JDBC/sample, some cases JDBC/example, but then your apps break. That means they don't work out of the box. So here, for example, I'm using JTA data source called as JDBC/sample. Now, yeah, that would work out of the box on Glassfish, but that doesn't make my application portable. So the idea here is, if I get rid of this JTA data source, then my persistence.xml actually maps to a default data source. That's what it automatically resolves to. That's sort of the JDBC name. Now, what is the underlying JDBC resource? That is application server specific. So from your application perspective, you don't care about that. All you care about is automatically connecting to the default data source. What is the JDBC resource? The application server, you go figure it out. So that's, improves your application portability. These are older properties. I don't want to show these. Hold on 1 second. Well, okay, hold on. Okay, that's where blocking helps. This is one of the blogs that I did on JPA 2.1 schema generation properties. What is that feature? That feature is primarily about how you can take a look at a JPA entity and ask your persistence provider to generate database tables from it. Now, up until now, like JPA 2, we could take a database table and create JPA entities out of it. That is possible. but there was no way, or at least a portable way, to say, take my entities and generate database tables out of it, or generate my database scripts out of it. So with JPA 2.1, you can actually do that. So there are properties like javax.persistence.schemaGeneration.database action. So all I'm saying is, in this case, just drop my tables and recreate them. Well, that's the action. That's nothing interesting. I'm saying, OK, fine, I can do that. But should I do that using scripts? Or that means you're going to bundle the scripts with your WAR file? Or should I do that purely using your JPA entities? So you take a JPA entity, you understand what the meaning is out of it, and then generate the database tables out of it. So that's possible. Here, for example, I'm saying javax persistence schema generation scripts.create target. That means whether it's going to be, so here I'm saying what are my scripts that will generate the database table, which is basically my DDL. Now you can bundle that as part of your application, and that will automatically be taken care of by the persistence provider. Similarly, dropping the tables. Not just that, you also have DML, or data manipulation language, that can be specified. So think about shipping a simple sample application or getting started with it. You can bundle your DDL, your DML, fully indexed, all of that packaged within one WAR file, and then giving it, deploying it on an application server, and the application becoming complete live at one instance. One of the places where we have made huge improvements is JTA 1.2. Well, not just JTA, but sort of making the platform a lot more cohesive and integrated. You can do user-managed transactions today, very easily. You can just inject a user transaction object, create it, commit, rollback, all of that is possible. But if you want to do container-managed transactions, that was only possible in using an EJB up until Java EE 6. We have changed that as part of Java EE 7. So JTA 1.2 introduces two new transactions. One of them is at transactionals, at transactional. So that means you can take that at transactional annotation, specify it on any POJO, CDI bean, whatever it is, specify on any POJO class or a method, and then the underlying container will automatically start and /commit/rollback a transaction for you. So let's take a look at that. Well, not this one here. So this is my very simple CDI bean. And you can see there is no stateless or stateful on this. It's not an EJB as such. Now I have tons of methods here, but the idea is on any POJO, I can specify the at transactional annotation, and it has all the semantics that the container managed transactions have in EJB. For example, requires, required, new, mandatory, all those attributes are available. You can specify as part of the annotation itself. But once you specify transactional, based upon the syntax over here, the semantics are automatically enforced for you. So for example, in this case, it's going to ensure that a transaction is automatically started and committed at the end of it. Okay. Well, I talked about two new features, so let me talk about the second feature in that case. So here is a simple bean, nothing fancy about it. The only new addition here is line 48, where I'm saying at transaction scoped. That's a new CDI scope introduced as part of JTA 1.2. All I'm saying is tie the instance of this bean or the life cycle of this bean to a transaction. That means if somebody tries to inject this bean within a transaction, give it an instance, Otherwise, do not give it do not give an instance of this bean. So I'm just saying, tie the instance of this bean to a transaction. So let's see how I will use it. Now I'm using, first of all, I'm injecting this bean twice here, my bean, or bean and bean2, okay. I have 3 scenarios. Well, the first one is, in this case, I'm explicitly starting a transaction and ending a transaction. It's a user transaction. I'm injecting a user transaction here. So if I'm starting a transaction and ending a transaction here. So in this case, I'm saying bean.getID and bean2.getID. Effectively, is returning the object identifier, because from the bean, all I'm saying is get the ID, or return the object. By default, it includes the object identifier. So in this case, I'm saying bean.getID and bean2.getID. So even though the bean is injected twice, but the proxy, because the way CDI works, if you're saying injection, it has a proxy and it gets the runtime instance, when it's required. So the 2 proxies will point to the same instance, because the bean is tied to a transaction. It's still the same transaction. Doesn't matter it's 2 proxies, but the bean instance is tied to the same transaction. So the 2 proxies point to the same bean. So effectively what I'm saying here is, even though the bean is being injected twice, I still get the same instance identifier for that particular bean. Now here, this is a different scenario. Remember, here I've committed the transaction already. Now I'm starting a new transaction and committing a new transaction. Exactly same as scenario 1, but the difference being, when the first transaction is committed, that bean is rolled out. That bean is given for garbage collection. So effectively, when I'm trying to inject bean here again, or at least trying to use the bean here again, both the proxies are going to point to the same instance, but that instance is going to be different from the one that was from a previous transaction, because this is a new transaction now. And finally, once this transaction is committed, that bean instance goes away. And here, when I'm trying to say bean.getID, then there is no transaction here. If there is no transaction, then it says, oh, there is no context that is active, so I cannot give you an instance of the bean. So clearly showing that the bean instance is tied to a transaction. You just by adding that transaction scope, the bean is automatically activated or passivated for you. So if I run this guy here, so if I do this, so here you can see, for example, this is scenario 1, bean1 injected twice. And the object identifier in both the cases is D12 and D12. So these are exactly same. The 2 proxies pointing to the same instance. Repeat of scenario 1 is a different transaction. These 2 are same, but different from the one over here. And finally, when I'm doing a bean outside a transaction, it's saying got expected context not active exception. So showing how add transactional and transaction scope really work with each other. Another big improvement as part of Java EE 7 platform itself is that CDI, or the context and dependency injection, is a really, really core component model. You can see all the changes that we have done, like at transactional is annotation, but effectively the implementation is done as interceptor binding, which is CDI interceptor binding. Same thing, transaction scoped is a CDI scope. So after receiving a huge feedback from the community, we literally surveyed 1,100 existing active users of Java EE, and there was an overwhelming majority of us saying enable CDI by default. So for example, in here, my webinf directory is empty. There is no beans.xml. I don't need a beans.xml to enable CDI. Frankly, it was very hard for me to kind of put my head around it when I saw CDI for the first time. Like, really? Wait, why do we need beans.xml? Why can't we enable it by default? But these inconsistencies happen. The CDI specification itself was introduced late in the game. Finally, we got it right. No beans.xml required. CDI is enabled by default. Well, and there are semantics defined on it is enabled for what. It says it's enabled for all the bean defining annotation. bean defining annotation. What is that? It goes into terms. The idea is any bean with the at stateless or stateful or with an explicit CDI scope. So you need to give at least an indication what beans you want to be injected. So any bean with a bean defining annotation that is stateless, stateful, or CDI scope will be automatically available for injection. Okay? So in this case, for example, if I look at my source packages, I have my bean here. On the bean, I just need to put at request scoped. I just made it at request scope, and in my servlet, if I try to inject my bean, well, of course, this is NetBeans is complaining, oh, CDI, you're trying to use CDI, there is no beans.xml. What the IDE does not know, I'm trying to trick it. Java E7 does not need a beans.xml. So here, the injection would just work out of the box. If I were to run it, I say inject the bean. I just say get hello Duke. But what's happening is on the bean, I'm invoking the method, and there is no beans.xml. You want to double check it? Let's do that. So go to target, look at my war file, look at my webinf, and I don't know why it included my specific web XML, but no beans.xml. So some of the key points here. As you can see, I can go on for a few hours on this, but I think I'm pretty much out of time, and I have about 1 minute for any questions if you have any. The question is, how does the batch API impact the existing ETL developers or the existing tool providers? So IBM is a specification lead for batch applications, and that's one thing that I'm trying to figure out, because Spring Batch is used pretty heavily, and that's sort of the unfortunately the de facto standard that people use in the industry. But the idea is there is a very close similarity between Spring Batch and the job XML. As a matter of fact, there were folks from VMware who were part of the expert group who were actually contributing pretty actively to the specification. So hopefully in the near future, we should have a compare and contrast kind of an article, hopefully providing a little bit more guidance and direction on how to get away from Spring Batch to batch applications as well. Thank you.